Okay, here are a couple more examples of integration by parts. So here's one, log x divided by x to the fifth. And so if I want to use by parts, I have to write this as a product. So I can do that if I bring the x to the fifth up to the top and write it like this. And now I've got a logarithmic piece and more or less a polynomial piece. It's closer to a polynomial than anything else. So I'll make u equal to log x, and dv will be equal to x to the negative fifth. The derivative of log x is 1 over x, and the antiderivative of x to the negative fifth, if I add 1 to the power, I get negative 4, so the coefficient will be negative 1/4, and we get x to the negative fourth, right? And then according to the by parts formula, I need u times v, so negative 1/4 x to the negative fourth times the log of x. Then I want to subtract from that the integral of the product of these two things. I've got a negative here, so, well, here, I'll just write this like this. And then 1 over x times x to the negative fourth. So I could write this as negative log x divided by 4x to the fourth, right? You don't have to, but when you write it like this, it looks more like the problem. It looks more like the format in which the problem was given. So that's just sort of like mathematical politeness, kind of. And here we get plus, right, from that 1/4. And this is x to the negative 1, and this is x to the negative 4. And so if I multiply them together, I get x to the negative fifth. And so applying the power rule one more time, negative log x divided by 4 times x to the fourth. And here, if I add 1 to the power, it's the same thing as going from here to here, right? In fact, I already did it, so let's just write this down. So here's this 1/4 times this negative 1/4 x to the negative fourth, plus maybe a constant. And then the final answer, sorry, my phone's going off, and my kids are going berserk downstairs. 1/16 times x to the negative fourth. So the antiderivative looks like that. Okay, so here's another example of integration by parts. This time we have the integral of x to the fifth times e to the x cubed. And we're going to have to doctor this up a little bit before we use parts, because if you look at this, let me get a piece of paper here. If you look at this, if we tried to make u equal to x to the fifth, and then dv equal to e to the x cubed, which is what we would do, right? Because x to the fifth is the polynomial piece, and the other one is the exponential piece. Then we can take the derivative of u easily enough, but when we try to anti-differentiate this thing, well, it would be hard. You know why? Because it doesn't exist. So that's not going to work. So before we apply by parts or do anything else with this, let's see if we can make a substitution to make this a little bit easier to look at. And so if I were going to make a substitution here, the natural thing, I think, to replace with a single variable would be the x cubed. I'm not going to use a u here because I want to save that for the by parts, but we could use like a t. If we made t equal to x cubed, then the derivative is 3x squared dx, right? Well, how does that help? Well, maybe it's easier to see if I write x to the fifth as x squared times x cubed. Like this. And then, if you see, this is a u, and this is a u, and for dt, it's not a u, it's a t, I'm sorry. And then this thing and this thing together make up dt. All I need is a 3, so I'll stick it in there. And then this thing and this thing together make up dt, right? Okay, and then after I make all of those substitutions, I get an integral that looks like this. 1/3. Here's a t times e to the t dt. T times e to the t dt. And this one's super easy to do by parts. If you make u equal to t and dv equal to e to the t, then du is 1, and v is still e to the t, and when you apply the by parts formula, you get t times e to the t minus the antiderivative of v times du, which is just this, and the antiderivative of e to the t is again e to the t, so the final result looks like this: 1/3 t e to the t minus 1/3 e to the t plus maybe a constant. And if you want to, you can factor it, but you don't have to. You can write it like this, or you can write it like this. They're both equally awesome. Oh, but one last thing that we need to do before we say that we're done is to replace the t's with what they're equal to in terms of x. So I would write my final answer, I guess, like this, since t is equal to x cubed. Write it like that. Yeah. Okay, this last example is plenty kooky. Let me show you what it looks like. E to the x times the cosine of x. It looks reasonable. So I'm going to do this by parts, and so I've got an exponential and a trigonometric, so I'll make the exponential part equal to u. So if we make u equal to e to the x, then dv is equal to cosine of x. And the derivative of u is the same as u. And the antiderivative of dv, that'll just be sine x, right? So when I apply the by parts formula, I need u times v, so e to the x times the sine of x, minus the product of v times du, so minus e to the x sine of x dx. Okay, and if you look at the derivative or the antiderivative that we have to work with here, it looks a lot like the one that we started with, right? Okay, well, we can try using parts again. Maybe dv is equal to sine of x, so du is still e to the x. And v, I guess, is going to be negative cosine of x, right? So here's this part. And then we're supposed to subtract this times this, so negative e to the x cosine of x minus the antiderivative of v times du. So another minus e to the x times the cosine of x dx. Let me resolve all of these pluses and minuses. So minus this minus, we'll turn them both into a plus, and then when I apply this subtraction, that'll make this one a plus and make this one go back to minus, right? So now I have the antiderivative of e to the x times the cosine of x is e to the x times the sine of x plus e to the x times the cosine of x minus the antiderivative of e to the x cosine of x dx. And so, do you see what's going to happen here? Like if we keep going like this is just going to keep flopping back and forth, right, between sine x and cosine x, and we'll be here all day writing this endless thing. But this is so clever. Let me show you how we get out of this. Notice that the thing that we want is right here, and the exact same thing, the thing that we want, is also right here. So what we're going to do is we're going to add this one over to the left. So to both sides, we're even going to do it in red. To both sides, we're going to add the antiderivative of e to the x cosine of x This is crazy, but it works. And so when we add those two things together, we get two of these over here. And over here we just get this, right? Because we just got rid of that. So e to the x sine of x plus e to the x cosine of x. And then all we need to do is divide by 2. And we're done. Pretty crazy, huh? So e to the x cosine of x is equal to 1/2 if I pull out the e to the x. And don't forget the constant.